Factories move millions of products every day, but how does a machine know where each and every box should go? Let's design a conveyor sorting system from scratch. Imagine a factory producing different products. Some products belong in one destination, others belong somewhere else. The machine must separate them automatically. If each and every decision had to be made by a human operator, definitely production will slow down dramatically. So, how does the machine truly know where each and every box should go? It all starts with a simple decision. Every sorting system begins with an item. This could be a package, a bottle, a box, or any product moving through a factory. The next component is the sensor. The sensor detects when an item reaches a specific position. Once the sensor detects an item, the control system must make a decision. Should the item continue straight or should it be redirected? The final component is the diverter. This mechanical device physically changes the path of the item. One simple decision creates multiple possible destinations. These four components form the foundation of countless automated systems used in factories around the world.
Every automated machine follows a simple pattern. It receives information in form of data. Then, it makes a decision. And finally, it performs an action. This process happens continuously while the machine is still running. In our conveyor system, the sensor does not make decisions, but only provides information by detecting what is happening in the physical world. The control system evaluates that information. This decision layer evaluates the information and determines the correct response.
And finally, the diverter carries out the decision physically.
So far, our system looks perfect. Every item is detected, every decision is correct, every item reaches its destination. But real factories face a problem. Machines fail, products get stuck, sensors malfunction, actuators respond too slowly. Imagine a box becomes stuck at the sorting point. The conveyor continues moving, but the item never leaves the area. To prevent damage, the system must constantly monitor itself. It must detect when something is taking longer than expected. When a fault is detected, the machine must respond safely before the problem becomes worse.
And this is where automation becomes far more interesting than simply moving boxes.
When a machine detects a problem, how does it know what to do next? Should it keep running? Should it stop? Should it wait for an operator? To answer this, the machine must know its current state.
Every industrial machine operates in different conditions called states. At any moment, the machine is usually in one state and only one state.
In the stop state, the machine is idle. Nothing moves, the system is waiting for a command. In the running state, the machine performs its intended task. Items move, sensors detect, actuators respond. If a serious problem occurs, the machine enters a fault state. Operations stop until the issue is resolved. The real challenge isn't the state themselves. It's knowing exactly where the machine should move from one state to another.
And that simple idea forms the foundation of modern automation systems.
now know that machines have different states, but the most important question remains: what tells the machine it's time to change? A machine changes state only when something happens. In automation, we call these events. An operator presses the start button. A sensor detects a product becomes stuck, or an emergency stop is activated. Every event produces a reaction. The machine doesn't guess. It responds according to how it was designed.
But how does the machine know which reaction is the correct one? That's where automation logic begins.
Although we have looked at simple conveyor sorting system, the same engineering principles are used in much larger automated systems. These ideas power warehouse automation, bottling plants, airport baggage handling, and modern manufacturing systems around the world.
Throughout this series, we'll start with this conveyor system and gradually build towards larger, more realistic automation projects. Along the way, you'll discover how engineers think, design, and solve industrial problems.